Now we'll dive into the Livy introduction part. We briefly covered in the previous discussion, mostly around explanations on TE and what is some of the backstory of why are we choosing TE. And now I think everybody understood the whole story, the motivation of using TE in blockchain. Why don't you help us run through your product and help us understand what you're building?
Sure. So, like, the main idea of Livy is that we want to bring this verifiable computation for anybody as accessible as possible. So, like, instead of having to boot everything, configure everything, need to understand like all these concepts of like DE is basically write your own code, write your own application, build that with Livy, and basically execute that with an attestation. So, essentially, what we're building is like an abstraction that allows you to compile any programming language or interpret a language. That's another topic we can discuss later, and basically execute that binary or that code basically to get the attestation, which means that every program that exists could be constructed like a rollup as well, where like we have the initial state, which is like the inputs for that program, and obviously the binary itself, which is going to generate an output plus an attestation. So with that, the other product that we're building is basically the provenance layer. The idea of the provenance layer is not only to track and basically provide this fully transparent traceability for anything that happens inside the computer, but also to provide the verifiable computation. So by abstracting away the execution on one side and basically creating this decentralized network, we can basically provide guaranteed provenance and traceability for any sort of computation.
That makes a lot of sense. Yeah. I think this sort of an infra, it's been heating up the concept of or the debate on verifiable computation. And I guess that mostly right now, the product market fit for verifiable computation, everybody's been discussing is like the clops on blobs, whether you should run it on a really high performance chain, which is a monolithic approach, or you build like a verifiable clop that just runs off chain, but you make it verifiable to connect it to the trustless environment like Ethereum's or Celestia, etc. And I think this is a trend that we're seeing. And that being the very first application, I feel like there's going to be way more coming along. And for that diversity of the applications that we are going to have, different trust requirements will exist. So one could say, I have to use the KPM. One could say, I care way more about performance and the cost. TE makes a lot more sense. And this is where Livy could come into play. And if there's someone say, this one has to be run by multi-party, then go for the consensus route, right? So depending on your application design, there could be like different trust settings that you can choose. And Livy will definitely be the very forefront of the decentralized TE game right there. I guess then it leads to a second question. So from a developer's perspective, if I want to use Livy, how would the interaction look like? Do I just write a code? And then do I need to package it in a certain way? Do you have an SDK? How does the whole workflow is going to look like?
Yeah, right now, basically, we're trying to figure out how to make the best developer experience. One of the things that we hate is that we don't want to use any DLS. I don't want anybody, my co-founder neither wants to have to learn anything else new to basically use the platform. So the way we are going to basically want to create all the abstractions is by basically you have your own code, which is executing something. And basically, by the primitive of you have an input for executing a program, and then you get the output. With that primitive, you can build abstractions for basically one, compiling your code, containerizing, well, making everything into a container, and then basically deploy that and then scale that for you. So that's the main primitive. So if a new developer wants to get into use Livy, for example, right now we only support Rust, but we plan to expand that for basically all the main programming languages. We can basically take your Rust code application, compile that into, we have to figure out like, we're basically working to make the whole CI/CD pipeline, but like the way it works right now, you get your programming language, you get your Rust code, we compile that code inside a TEE, and basically we execute that every time you make a request. Every time you make a request, you're going to get basically the attestation, and that's the only thing that you need. You don't need to learn anything else. It's basically writing your own application, and then Livy is going to take care for everything.
Why is it important to compile it in the container, in the TE, instead of maybe just giving you a binary, or does it matter?
Yeah. So there is two cases here. If you want to provide a binary, you're going to be able to do that eventually. We'll want to add an option. So if you don't want to trust the infrastructure, build the whole binary for you, you can provide a binary, which means that you are basically like the trust assumption. But let's say you want to prove that you are executing a binary to your customers. So the only way to do that is basically with a sort of like a proof. So if you compile your code in a DEE, and then you have an attestation for that compilation by using one of the compilers that we're going to be basically open source. So you can like trust the binary executing and compiling that your program, it's basically this one we're publicly sharing. And then basically we compile your program, which basically with this binary, you basically have the proof that you are getting this binary or this hash out of your code, which basically means that you can prove to your customers, you can prove to your users, or you can prove to like anybody that the bill has done correctly. And you can also compare like the binary that we're basically getting is the same thing that you are getting in your computer. So like it's fully open to that. And then you can verify that every time that you're using that binary basically. So it's very important to basically have these trusted compilations as well.
Yeah. And also, I think there's another important thing is depending on the hardware, depending on I guess, the hardware setting, the compilation result might be different because the program binaries are often very much aligned with the machine's, I guess, like hardware setting. I guess, do you find ways to unify that standard, making sure the compilation is done in a unified way so that for every execution, you're getting exactly the same compilation results, or it doesn't matter that much?
Yeah, it does matter. Let's say you want to run, let's say you compile your program for Linux or like Windows, it's going to change the binary. The way we have basically managed to do that, and like the way we can provide deterministic builds is basically by running like the same environment, which in this case is for Linux basically. And if you were to compile your program with the same parameters, with the same program to basically run inside like Livy, you would basically get this deterministic build yourself. Obviously, in order to identify the programs and identify versions and all of that, it's basically important to have deterministic builds. So let's say you forget and you basically delete your binary, but you want to have the same ID. You can basically use the same program, the same binary to compile the same program. It's going to get you the same output every time.
Yeah.
Actually, on this, just a side divergent thing, I feel there may be a regular Web2 use case in this, which is whenever you download a lot of binaries or code, whether it's directly from the browser or even from NPM, there is usually a hash you have to check it against, right? There's some sort of thing where you know that you're downloading it from the right developer, that there's no bugs in it, that it was compiled properly. I wonder if there's a way for Livy to be used in that world too, where there is some way for them to verify that a piece of code was generated by the right group of people.
Yeah, this is actually very easy. Like the Provenance layer, one of the inputs that you have, it's basically the file hash, which is basically the binary you're executing. And every time you're going to execute a program, it's going to have that as part of the attestation. So basically, if you have the inputs, you can verify that the inputs and the output, you can verify the attestation with the file hash that they're telling you to use. Let's say you compile a program and you compile a program and it gets the hash 123, for example. If you execute the program 123 with the output of whatever you use, you're going to get an output. If you get all of this information, you can basically generate the same hash that the attestation is going to provide. If everything matches, you basically have the right execution on the right program. If something is different with the hash that you get once you verify the attestation, basically something has been wrong.
I wonder if there's even a step further that you can take it where when you're doing the inference, you're not sure you're getting maybe there's like a person at the back just typing stuff away, right? I'm wondering if there's something that can be used with Livy in that world where you're verifying that some inference was done correctly or that, I don't know, I'm just spitballing here.
It is actually like one of the problems that we want to solve with like verifiable compilations, because if you have a verifiable compilation, so you can prove to everybody, hey, this is my hash that I'm going to be using for basically running your program. And every time you make an execution, you need to have that hash. Otherwise, the verification of the attestation is going to fail. It's going to generate correctly, but you won't be able to verify that the programming or like the hash of the developer is not the same, because I'm not getting the same output attestation if I do it myself. So basically, for any verifiable compilation that you have an attestation for, that you're executing as well inside a TEE, you're basically going to be able to say, okay, the developer is saying that I'm getting this hash every time I'm making an execution in your app, but I'm basically going to be able to verify that because I have the input on the output of that execution. And basically, if the developer tells me that I'm using this hash one in my program, as a user, I'm going to be able to verify that. So this is great because you remove the developer trust, and then you know basically that the developer is basically behaving correctly for everybody. This is like in financial cases, order book, this is super important because you don't know exactly, or like oracles, you don't know exactly if the developer is behaving the way they're supposed to behave. And basically, you don't know exactly what's happening underneath. But if you have open source code and then you have an attestation that you're running that binary, you don't have any mistakes. And then you can verify everything that is happening in the computer, basically.
I'm also thinking like for compilation verifiability in ZK, there's ways for accelerating some of the computation, which is via lookup tables. And I think in TEE, it would be even possible, let's say, if I have a code that is pre-compiled, like before compilation, and then I compile it, maybe in a TEE, and I only do it once. And then I get the compiled result, and then since the original code and the compiled result, and also the actual hardware and the VM environments, all of that packaged together and then send it to something like Celestia. And then stores it there. And then every time when I want to run this computation, instead of recompiling every single time in the container, I just need to give them this sort of Celestia data reference and then let it verify. And then after it verify, I can just use the compiled code binary directly and then just run it with the code. The reason why I feel like that's more efficient. It's just like, let's say there's like let's say a model, right? A model is going to be, and you don't want to compile that every single time. You want to have some sort of a container or some sort of something that you can continuously do on top of a certain, instead of starting beginning every single time. So I guess that's one thing that I thought could be possible. And yeah, before you answer this question, another question to follow up would be, I briefly talked about Celestia. I also wonder how you guys are integrating with the DA solution in your system. So yeah, that's two questions there.
Yeah, that's actually a super good question. One of the importance for having verifiable compilations as well is basically we are providing that service for developers. So developers doesn't need to compile a program every time it executes. So we store a program binary for the user and basically abstract that away. But then we need some way to basically prove to the users that we're using the program they provide us. So one, we protect ourselves and the customers by basically providing this attestation. So I can provide them, okay, I'm executing the binary you're telling me I'm executing, but also they have the proof to their customers that they're getting that execution done. So basically, the way it looks, you basically would compile a program with Livy, you would have an attestation, and that program is going to be attested. So we can basically prove that the compilation was done correctly. And every time we make that execution, we can provide the attestation for everybody. So I can provide as Livy, I can provide the attestation for the developer. So they're essentially getting the same program they compile. And the users at the same time can provide that the developer is actually running and using the program that they're telling their users. So this way is one of the important things about Livy and like how we can provide this traceability. Basically with the attestation, the information is going to match. And this is how we solve that problem. And then the way we use Celestia, and we're going to be using Celestia, it's basically for the provenance layer. In order to have like settlement in a blockchain, with every rollup, you need to have any sort of solution for that availability. And the way we're basically going to be using Celestia is to basically publish any public execution and attestation in order to basically verify and have that settlement. Also, one of the key points that Celestia just launched into production is also private DA, which is extremely helpful in the case that some applications doesn't want to provide public execution because it could be like the input cannot be exposed, the output cannot be exposed. So the way Celestia is handling that, you have an encryption for that. I don't know exactly how they work, but like basically it could be decrypted if you have a particular key, but basically provides like the same guarantees of any DA, but you would need this extra key in order to decrypt the information inside like the blob that you post.
Yeah. The private blob thing, the private DA thing, I think it's very exciting. It's very pioneering too. And not just I think EigenDA, it's also working towards it. It's a very sophisticated system. Yeah, maybe we can have another episode that talks about it.
Yeah, that would be great. Nuke, one of the Celestia developers, was in New York. He was giving a wonderful talk on how it works. And it's definitely one of the most exciting things I've seen in DA for the last probably year.
Essentially, once you start to have like verifiable computation and if you want to prove that you have done something correctly, you have to find a way to either you build your own private data infra, or now we have an option to actually just tap into a public infra that provides private data. That sounds a little weird. It's a trustless infra everybody can use for your private data exposure, which is only mostly for verifiability. So let's say if I have my own data, I don't want to share it publicly, I can still use that DA to verify and see if my data is indeed included in this current commitment, something like that. It's a little bit abstract, but I guess we'll have another episode that explains this in detail. Yeah, I think this is really helpful in understanding Livy and really help us mapping where Livy really lives in this giant ecosystem of verifiability. And I think this is like one big vertical where there's ZKVM, there's like TEE, there's going to be Livy in this category, and there's going to be some others. But all these are under the big umbrella of trustless computation, verifiable computation itself. And then you talked about some of the camera examples and some of the examples that we can build. Why don't you help us walk through some of your use cases that as a developer, what can I do? What can I achieve using you guys? And what are some of the specific use cases?
Yeah, this is like the question it's really generic because you can essentially use it for any sort of computation that you need to verify. This is amazing. But like some particular use cases could be, for example, into DeFi, if you want to have order books that are verifiable, which could be extremely particular if you want to basically prove to everybody that you're fair with everybody. Another use case could be oracles, where you want to get some information to the blockchain and you don't want to go with all these problems, or you want to basically have any sort of data that is not provided by one of the existing oracle providers. So basically you want to bring, let's say, how much cows do I have in my farm, for example, which is extremely weird, but like you could potentially get the number of cows if you have an API or you have a trusted data source for that. Basically, you would fetch that out, and then the output of your program would be basically like 100 cows, for example. And then you can prove that and basically get that into the blockchains. Oracles is also one of those use cases. And also attestation services by default. So you have Ethereum attestation services, you have IP protocols. And then the problem with that is that you have the entry point of data, which is centralized trusted by an attestation service. But if you want to have derivatives of your information, it's very complex to track that out. So one of the properties of Livy is basically the traceability of anything. So if you have an attested something, let's say you have a picture that you have attested that is from somebody in particular, you can transform that image in a way that the derivative image is going to be basically attached to the original image with an attestation that we would provide. So that's also one of the use cases that otherwise it's very complex to do. And basically with ZK and the concept that we built on February also proved that it's basically extremely expensive to do with ZK. With Livy, we pretty much solved that problem. And if you need to have, for example, traceability throughout any IP, that would be great.
Would you say you decided to go on TE route because you just feel like ZK is not going to work?
Well,
from your personal experience? Not okay, maybe that's too harsh. Not going to work, but it's just like you think TE is a better solution.
There is 3 ways of basically accomplishing verifiable computation. It's ZK, optimistic, and TEEs. So with TEEs, essentially, we have close to no overhead, which means that the cost is basically extremely low. And also it allows you to run anything without having to learn. I mean, if you abstract it correctly, without having to learn anything. So that's extremely excited for me. And that's one of the reasons why I choose TEEs. And then obviously, because like developers want to use something that is simple and it works. And if you basically need to transform the way you have been working for the last decade, let's say you're a senior engineer who has been working with Go forever. unless you have a CK VM specifically for Go, you cannot use CK in a simple way. Otherwise, you need to learn circuits, basically. So with TEEs, you can take that Go program and verify anything, basically. So it's very compelling to have TEs for that, for those reasons. One, performance, and also the developer experience that you can achieve as well. It's not like CK isn't going to make it. I truly feel like CK, it has like extremely important use cases, but the way we want to approach verifiability needs to be more open and more generic for everybody. So people just don't build things. This is like the meme for everybody, but the
Yeah.
idea is that anybody can build things and should be verifiable.
So ZK is for some extremely important, some use cases, but T is for everybody. Nice.
So
I'm
that's actually,
not trying to pick up a fight here, but yeah, I'm just like, yeah, just kidding here. But yeah, that's a good summary. A lot of the overhead problem with ZK, TE just have, it's by design, by nature, it doesn't have that much overhead. It's superior by the nature itself. And even though as much as we try to optimize ZK, probably still won't reach the level of TEE. And yeah, and I guess another thing about TEE is that anything that you can build with ZK, you can technically build the same thing with TEE. Like we say ZK TLS. Technically, you can also do TEE TLS if you want. But and some of the others, anything that AVS is doing, you guys can do it too. But it's per use cases, they will have different security and performance requirements. So they will have to choose a stack to do it. So that's my take around it. And I see a world where all of these will coexist and every developer will have their choice of choosing which one. And there comes to the next question will be about, this is actually asking myself. So yeah, Chainless. So if you watched our previous episode, we talked about Chainless, which is that paradigm is designing a verifiable applications. There's a lot of like-minded people around the world who are sharing the same ideas. We originally proposed it as A to Z app. Now we are rebranding it into Chainless. And there's also another one from Layer Zero and such thing called the VAPs, verifiable apps. And EigenLayer obviously is a pioneer in this space way earlier than both of us. They were really tackling this off-chain execution and on-chain verifiability, this concept. And I guess like the part that we've been talking about, the ZK, the TEE, and some AVS, all of these, they're the trust bridge that bridge the off-chain that is not trustless execution to convert it into a trustless record and store it, commit it on the trustless state storage, and which in this case is Ethereum or EigenLayer or some of the others. And all of the, so basically act as a bridge, is bridging the Web 2 computation and convert it into a trustless computation, which becomes a Web 3 computation or a Web 3 service. And one of the bridge path is TEE. And one of the forefront of this will be Livy. Yeah. And I guess like that kind of concludes my thoughts around and also some of the questions for Livy and TEE in general. I want to give the mic to Rongxing to ask any final questions.
I'm wondering if the earlier discussion around TEs and ZK, the trade-off is that with ZK, the idea is that without any additional hardware, can we develop these like completely verifiable systems, right? Like just doing it with the existing hardware requirement. TE saying in this future, let's say we have new hardware, then you can use this new set of hardware. So I think that's maybe the trade-off that I see, which is
I'll chime in a bit and then I'll pass it
Yeah.
to Saul. For TEE, there is really no new hardware. I think ZK is more new hardware than TEE, in my understanding, because TEE has been shipped in a lot of later generations of Intel chips and a lot of even mobile chips, etc. A lot of these hardware already equipped with this components. It's just we're not using it, or at least we're not using it in blockchain. But for ZK, there's Fabric Crypto, I think that's their name, who's building like ASICs for ZK. And there's still light years away. There's still a long time that we have to wait till we see it in production and then ship and then start really accelerating ZK. Yes, right now we can run it in GPU, we can run it in these, but yeah, we can technically run it in any computation. Yes, but to really optimize it and to a level where it can just mass adopt, there's no custom hardware for ZK, but there is custom hardware for T. I guess that's the difference there.
Yeah. But I think what you're saying is that with Fabric and even like when we had the discussion with like Ingoyama, all these, they're kind of like the optimization to generate these.
Yes.
Like
It's a
technically
huge
you
step
don't,
forward.
yeah, like massive improvement, but technically you don't need them. You can use your, I don't know how usable it is.
It's sort of like with Bitcoin. Do you need ASICs to run the Bitcoin network? Probably you would. You can do that with GPUs, but it's going to be like 100 times slower than just using a dedicated chip for that particular problem. So with CK, you have those particular problems, and then you can just dedicate your whole chip to solve and makes
Right.
everything more efficient.
I get your point, Rongxing. It's like for ZK, yes, you can run it. Like it's just whether the efficiency problem. So you can still run in any sort of computation. But of course, like if your computation is too large, it requires a lot of memory. No, you can't run it on your phone. You have to run it on a server with a really large RAM. But that on the side is just like AI model. If it's small enough, it can run it on your edge device. If it's a really large model, you run it on a server. That's that. But for TE, yes, it's a 0 or 1 problem. It's like either you have that TE in your chip or you don't. If you don't have it, you can't run TE. That is the answer.
And also, one of the things that I truly think coming with TE is that I love the take you have. It's like the chip already exists, but we are not using it. That's totally right. There is some great use cases for TEs, like storing your private keys for Apple, which is like probably one of the biggest or like one of the most innovative companies that when it comes to TEs actually has pushed that to everybody. But also, if you just enable any sort of computation with like your iPhone, you basically have like verifiability for anything you're executing. And then the next thing, and like what it could be theoretically done in the future, this is a concept I talked with my CTO. He basically gave me the idea. It's like, wait a minute, this is actually possible. You could actually have devices controlled by smart contracts through TEE, which is like mind blowing. It's like, how do you do that? But like, if basically you have a TEE, you can basically have a request for a smart contract, get that information, and if you're basically whitelisted, you can basically proceed and use that device for that particular use. So it basically brings another layer of security that otherwise would be impossible to accomplish, basically.
That makes sense. The authentication process happen inside TE, and then you'll be able to run any, I guess, accept any commands and then run it off on your edge devices. Yeah, cool. That is actually really cool. Yeah. So now instead of one way, now actually it's the other. It's both ways.
Yep.
You can actually communicate with blockchain instead of just talking to blockchain.
That's totally right. Yeah, that's totally that's like super simple on the concept. It's just basically a problem of distribution.
Actually, maybe one quick thing on the use case side. I think that a group from Cornell Tech, they had the paper called Liquefaction, which is allowing people to do voting on DAOs, essentially sell their votes, and to allow people to buy up these votes and for people to hide their private keys inside of these TEs and to sell their rights to the votes. I think the early use cases, just going back a little bit, I think will be very novel, and I actually will think people are going to attempt to do things like that's maybe frowned upon initially, like selling your votes in DAOs. Or I saw that Andrew Miller had something where they're allowing people to hide their Twitter access token inside of TEs. And then for you to buy the right to post on their Twitter account. So if I pay this TE, like, I don't know, 1 ETH, and then it'll automatically post a tweet.
I saw that.
Right. Yeah. So I'm like, okay, that's cool. Definitely a little bit against these terms of services, but essentially around access to accounts and building trust for that, which I think is very interesting. Maybe one last thing on my side is actually just around maybe the business of this. Like, how do you think about that? Do you think about it more as software that I'm selling, like an open source, like HashiCorp model? Do you think of it as cloud service? Do you think of it as like hardware one day? How do you think about that?
Yeah, this is a great question, actually. I think that TEs by itself, it's like another business. The idea of Livy is basically abstracting this great product like developers and enabling and solving the main problem. So the focus of developers can be basically building, and then we abstract them away from like infrastructure, scaling, observability of anything. So it's basically like software, like what we're offering. It's not obviously we're going to be providing the compute, but the main focus and the main value that we're going to be providing is the simplicity of you just focus on your app, you develop your application, and then you have these features by default. So I think that's the main value proposition that we can bring to the table. Whereas if you were to provide any DE service, it's okay. It's just another provider. I'm just buying this computer and basically selling as a service where the value is obviously it's a big value to have this computation, but I think there's so many things that you can build on the product on top of the DEs.
So let me just clarify for the audience then. The idea is that it's going to be like is it going to be something like HashiCorp's approach where you have, for instance, you provide stuff like Vagrant or like all these, what is that?
I
called?
think
Yeah.
of it as a single click solution where you have like extremely simplified way to understand how much you're going to pay, extremely simplified way of deploying your applications, and basically no overhead or no complications. Or basically, okay, I have an application. I have a good competitor, or not a competitor, but like a good comparison would be Vercel. Like Vercel is basically a tool for AWS, essentially. So they
Yeah.
basically have built this product on top that basically enables, at the beginning was just websites. Now it's websites plus compute because they have Next.js, and basically they can provide also
Yes.
like a backend service. So they basically build a model on simplifying running websites and basically creating infrastructure for websites. So this is a tiny bit different because with websites, you can have straight improvements by basically, for example, having static files, which is like the most efficient way of distributing content. You don't have to run any computation to return the content. It's just static. So they have achieved that infrastructure, and they basically have built on top of observability, scaling. So they not only can have this super simple flow, but also they can predict what's going to be your cost if you have a million requests because they have built all the infrastructure to provide that abstraction as well. So you don't need to worry about the invoice from AWS. You don't need to worry about scaling your infrastructure. You don't need to worry about different problems that the product could have. So it's basically like a one-click solution for deploying your application, and you know it's always going to work. So we could say that Livy, or one of the Livy goals for the next 5 years, is basically abstracting away how we build applications into blockchains, or the other way around, to how can we make existing Web2 applications blockchain secure, basically. So instead of having to learn all these complexities, you just use Livy, you click a button, you deploy your app, and it's not only going to provide the security guarantees, but also like a scale for you and basically provide these other abstractions that you might need as a company. So this is how the product looks. So literally that's what we have accomplished right now with Rust. So we would basically come here. This is where everything is going to fail now, by the way. Because you basically go into the console.
Demo gods.
You would basically log into the console. And basically, this is like services that we already have. So you would add a new service. You would connect your GitHub repository. You would like basically add like the repository that you want to use. Okay, this is GitHub slot. You can basically select any repository. Let's say CK Media. No, CK Editor, like the one we use for basically editor. Where it is? Wait a minute. I don't know where's my repo. Where is it? I don't find that. CK Hyperliquid. Let's do this. So basically, we would get the repository now, and then basically we can get the branches, we can explore the files, and if there is a Rust program here, it's going to automatically detect the program. So basically now we are taking the main file, and then basically this should be around server. This is everything that we have. Okay, we need to add all these blocks manually. Never mind. It's a tiny bit more complex working on the UX. This is going to be removed once we have the compiler engine working, where basically this is going to be basically fetching with the GitHub.
Yeah,
the idea is that you're going to get all the files, and basically once you compile the service, now you're going to have CK Hyperliquid working inside Livy. This is how it's going to be. So like, you basically connect your GitHub repository, and basically it's going to compile for you. And then basically you're going to have the attestation for the compilation. And then basically you're going to be able, like, once the program is compiled, you're going to be able to like input any parameters, or if you have, let's say, this is like a Lambda function where it's like you have an execution, and basically every time you have an input from like non-persistent services, this is one of the tastes that we can have, which is like you input something into your console, you execute it like a console program, and then you get something back. Whereas if you want to have a persistent service, it could be like an API. So you just send like the HTTP request to your service, we expose ports for you, and then basically you get the output of that, which is pretty much the same idea. This is how it's going to look. Obviously, it's not going to compile now, but like the point is that once compiled with all the files, by the way, this compilation is going to fail because we didn't take all the files. Basically, it's going to generate the binary for you that you can execute anytime, and it's going to be basically exposed by an API.
And just to be clear, you're not providing the hardware at all. You're just connecting to, let's say, like AWS, for instance, or some other like cloud. And what you're really doing is this like compilation process. And then you're going to ship it off. Maybe users can select what cloud they want, or like multi-cloud, or
The idea is that we want to make it as simple as possible. So if you are like an enterprise company and need X particular cloud in particular for performance, we could probably do that as long as they have the hardware in that particular region. But like the main idea for the most of the users is that it needs to be extremely simple. You just have your program, you compile your program, and you execute your program. We did like the main thing. So basically, we're providing the abstractions to like get your program into running. Let's forget about TEs. What's the main problem? The main problem that developers have when they're juniors and they don't know how to deploy code. How can I deploy my code in production? I have a backend that works in my computer, but my app isn't going to be deployed on localhost. I need something to deploy it up. So that's the bare minimum that we're doing. But on top of that, we're abstracting TEs. So not only you're going to be able to have like your program deployed, but also verify every time you make an execution, which is like the main abstraction that we are working. And on top of that, you're going to have the execution and the auto scaling. So you don't need even to worry about like how my infrastructure is going to look like. So it's going to be very simple, straight to the point. You get your GitHub connected into the website, you compile, and then you are good to go.
Appreciate it. That's all the questions that I have.
Awesome. This has been a really great session. I think I learned a ton, and we definitely discussed a lot of ideas too. Maybe something that we can see in the future that is implemented in Livy. Any final words from Sal for those episodes? Anything you want our audience to know?
Yeah, I think it's been great. First thing, thank you for having me here. Second, if you want to have a conversation and basically use Livy for testing, I think we are basically open to any conversation. So you can reach out to me in any socials. I'm so great everywhere. We'll be looking forward to have any conversation. And again, thank you for having me here. I have so much fun.
Cool. All right. Thank you so much. And yeah, thanks to everyone for tuned in for so long. And I hope you learned a lot. And yeah, we'll see you in the next episode. Thank you.